So in this video, we're going to do like a quick review of just some of the basics about logarithms, so how they work and their graphs and stuff. Okay, so one of the things to remember with logarithms is that they're motivated from finding the inverse of an exponential function. So let's say that I wanted to find the inverse of 3 to the x. Okay, so if we went through the work for this, so first I'd say, okay, so I've got y equals 3 to the x. I would switch my x and my y. And then when I try to solve for y, like, we don't have math to do that. That's like where we run into the issue. And so this is where we need a logarithm. So we need like a new function basically to do this. And so let me tell you what a logarithm is so that we can solve this. So a logarithm by definition, so you have all real numbers y, and then all positive a and x's. A can't be 1. So y equals log base a of x. That's how we read it. Y equals log base a of x. This is equivalent. This is the same as x equals a to the y. So notice, like, why does this matter? So this is the equation that I have right now, so something of this form. And if I'm trying to solve for y, then I say, oh, I know that that's equivalent to this. And look, this is in terms of y equals. This is not. So going back to our original problem then, the way I would write this is y equals log base 3 of x. So this would be f inverse equals log base 3 of x. So that's where this conversation kind of comes up. And I'll just leave the definition up there if you need to pause and write it down or anything. So now let's just pivot to reminding ourselves how this definition works. So I have a bunch of exponential equations and I just want to write them in logarithmic form. So remember, the thing here is that y equals log base a of x. That is equivalent to x equals a to the y. Okay, so when I try to apply that to this first one, 3 squared equals 9. So the base of this becomes the base of my log base 3. And then where I have my equals to, that's going to go log base 3 of 9 equals 2. So the way that you can think about this, like, what does a logarithm mean? It's what do you raise the 3 to get it to equal 9? That's basically what a logarithm is trying to get to. So you can try to internalize that when you're writing this out. So what I would recommend, just to kind of get you back in the swing of things, is to just write these two out, do it on your own time, and just take a second to do it, and then hit play when you think you've got it. Okay, so I've got log base 5 of 1 equals 0, and log base 4 of 1 over 16 equals negative 2. Okay, cool. So there are my equations from exponential form to logarithmic form. And just to go the other way, just to kind of cement this definition, now we'll go from logarithmic form to exponential form. And in some ways, I think this is easier because, again, so I'm going to have that y equals log base a of x. So this is equivalent to x equals a to the y. Okay, so when you're rearranging this, so this is going to be 3, so the base is also the base for the exponent. 3 to the 0 equals 1. Okay, so the thing I want to point out with this, if you ever get stuck and you forget the definition, like, this is mathematically true, right? This is the only way you can really arrange these 3 numbers to make a mathematically true statement. So if you ever are not sure, like, just ask yourself, is what you wrote down, is it true? So once again, I would just recommend that you pause for a second and try these two on your own just to wrap your head around it, and then hit play when you're ready. Remember, math is not a spectator sport. Okay, so for this next one, I have 5 to the 3rd equals 125, and then I have 3 to the 4th equals 81. Okay, so now I just want to talk about, like, how we can use the definition of a logarithm just to solve some basic logarithmic equations. So if I have something like log base x of 8 equals a, so I want to solve for x in this case. So to do this, really what you've got to do is you write this in its exponential form. And then once you get it in exponential form, you just got to kind of use your noggin and think about what makes sense. Now, in this particular form of the equation, I can just take the cube root of each side to get that x would have to equal 2. Okay, so let's pivot to another way I could ask this question. What if I had log base 3 of x equals negative 2? So again, the key here is to write this in exponential form. 3 to the negative 2 equals x. Well, now that I've rewritten this, right, there's nothing for me to even really solve. I just have to evaluate 3 to the negative second. So 3 to the negative second is going to be 1 over 3 squared, which means that x equals 1 over 9. And finally, so I have c here. So maybe you just want to pause for a second and think about it and then hit play when you're ready. So I've got 49 to the x is going to equal 7. So now in this case, I do have to think a little bit about what exponent could I take the 49 to make this work. So you kind of just have to think through what you know. So if I take the square root of 49, the square root of 49 is equal to 7. So if my x is equal to 1/2, which is equivalent to a square root, that would work. So exponential equations, if you just kind of use the definition of a logarithm and then just kind of put your thinking cap on, you can figure out how to solve these. The last thing I want to mention in this video with just some of the basics of logarithms, what comes up a lot is the graph of a logarithm. And this is a little counterintuitive. Like you have to still use the definition, I guess, is what I'm saying, to figure out how to graph this. So, okay, let's unpack this. So I've got f of x equals log base 2 of x. For our purposes, I want to rethink of this as y equals log base 2 of x. And then the easiest way to graph this is to rewrite this in its exponential form. So rewriting things in its exponential form with logarithms, it just comes up a lot. It's very handy. So I'm going to think of this now as 2 to the y equals x. I want to think of it this way because this is much easier to evaluate. And so now that I have this figured out, the easiest way to evaluate this is to plug numbers in for the y. And if you think about that for just a moment, that's just a little different from how we normally evaluate functions, right? Usually we choose x's first and plug those in. But in this case, it makes more sense to choose the y's first. So we're just going to make that little tweak in logic. And since it's exponential, I just want to get a handful of points just to get the shape of it. So I'm going to evaluate these points here. And so maybe you just want to pause for a second to try to evaluate this on your own before I show them to you. Okay, so starting with negative 2, so if I just take 2 to the negative second, so remember that's going to give me 1 over 2 squared, which equals 1/4. And then using similar logic for negative 1, so 2 to the negative first is 1/2. Anything to the 0 power is 1. 2 to the first is 2, and 2 squared is 4. So there are all my points. So then I just want to take a moment to graph these points. And so I would recommend that you also just take a moment to graph these points. So I've got all these points, well, plotted, not graphed, I guess, but plotted. And okay, so now that I have this all set up, so you just have to think to yourself, so I see this shape going this way. And okay, cool. So will these x values ever go into something negative? And if you remember when we were talking about exponential functions, so we talked about how when you've got an equation like this, it'll never go negative. So since we're talking about the inverse equation, the x's will never go negative. Before we were talking about how the y's would never go negative. So anyways, I bring that up because when I draw this, I just want to make sure that the graph comes close to the y-axis, but it never crosses because my x's will never go negative in this scenario. Okay, so just a couple things I want to point out here. So first of all, like 3 points to help you figure out how the graph looks would be taking y equals -1, y equals 0, y equals 1, and these are the associated points. So it depends on what your base is, but these are kind of the 3 main points that will help you get the graph, and then you just remember the shape of it. The next thing I want to say is that the graph of log base a of x, it takes this sort of shape when a is greater than 1. We'll talk about the other shape it can take in one moment. The y-axis in this graph is an asymptote, and the domain goes from 0 to infinity, and the range goes from -infinity to infinity. So I think an interesting exercise for you is to then compare this graph. I had another video where we talked about graphs of exponentials. So just look at the information for those two graphs, because for an exponential, the domain and range were flipped. And that's actually like one of the properties of an inverse. The domain and range for inverses get flipped, and that's exactly what happened here. The asymptote also flipped. We went from having the x-axis as an asymptote to the y-axis as an asymptote. So just as an interesting thought exercise, like just review what we talked about before with exponentials, just to see like how the two graphs, they truly do fulfill that inverse relationship. So the other graph I want to talk about is log base 1/2 of x. So we're going to do the exact same trick. I'm going to take 1/2 to the y equals x. And so once again, I'll just choose my y's first. And so then I can go through and evaluate these points that you see here. And again, maybe you just want to pause for a second, take a moment to evaluate these on your own before I show you the answer. Okay, so I've got 1/2 to the -2nd. So that means to get rid of the negative exponent, I flip the inside. So this just really becomes 2 squared, so this equals 4. And then I can do a similar thing for -1, so this will just equal 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2, and 1/2 squared will be 1/4. So here are all the points. And so once again, now what I'm going to do is I'm going to go ahead and plot these points on a graph. So maybe you want to just take a moment to do that before I show you how this looks. You can just finish this kind of on your own and then hit play. So, okay, I've got my points. Boop, 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 boop. And, okay, so I draw my graph. Ta-da! Okay, so we're all good. All right, so let's discuss now this other type of shape of the graph. It's still the same 3 points that you use to kind of carve out the shape, but the graph of log base a of x takes this sort of shape when your a is between 0 and 1. So it should feel very similar to some of the stuff we were talking about with exponentials. The y-axis is still an asymptote, and the domain and range are still the same. Okay, so these are inverse functions, and I've been talking about this in a lot of my video series. So the translations still work the same. So let's just explore like how you could graph a logarithm. These are always a little tricky to graph. So I've got log base 2 of x minus 1 plus 1 equals y. So I want to graph this function. Okay, so there's lots of ways that you can do this. I will just throw out what I think is maybe like the easiest way to do this in my mind. So first think about just the graph of log base 2 of x. Okay, so I was just talking about this, those like 3 main points. Okay, so the 3 main points that you would normally have would be 1, 0, and then you would have -1, 1/2, and then you would have, 2, 1. So you can figure that out from doing 2 to the y equals x, and then you just plug in, for your y's, you plug in -1, 0, and 1, and these would be the 3 points that you get. So that's where that came from, those 3 main points I was telling you about. This is how you get to the graph of log base 2 of x equals y. So what happens with this graph here? So how do we think through that? Well, this graph is going to move right 1 and also up 1. So what you can do if you're not sure about like how you want to graph this, and it can be hard to solve this and make a table for this, you can think of these 3 points that you know will get you the shape, and then you can just move them. So I'm going to take this point and move it right 1 and up 1. So move it here. I'll take this point, I'll move it right 1, up 1. Okay, so that's now overlapping the green point, and then where this green point was, I'll move it right 1 and up 1. So now I've like carved out the shape for my translated graph. And the other thing I want to do, so I know that my y-axis was an asymptote, and what I'm going to do is I'm just going to move that over to the right 1. So I'm just going to note my new asymptote. And now I can connect these points. I know the general shape of the logarithm. Boom, there you go. So these are definitely a little trickier to graph. So you have to kind of think about what you know about the graph and then just move those points. But if you know the general shape, you can still get the job done and the translations still work. All right, and so that brings us to the end of this video. We've got a lot more things to talk about with logarithms, so I will catch you guys in the next one.